No. Because 60 is being divided by the sum of x plus 2. Not x individually and 2 individually. Okay. Does this make sense? Sort of, kind of? All right. Let's see what happens when we're missing a variable somewhere.
What if your coefficient isn't 1?
I'm going to do that too, but let's do this one first. Polynomial divided by a binomial. I can use synthetic division. Make sure the coefficient of z in that last part is 1, and it is. Make sure your z's are in descending order, and they are. But are they all there? No. So, how do I make room? Z to the 5th, what should be next? Z to the 4th. But there's really not one there, so I'm going to put a 0 coefficient. I'm making room. Next should be a z cubed, but I really don't have one, so I'm going to put a 0 coefficient. Then I have z squared, and then next should be what? Z, but there is no z, so I'm going to insert 0z, and then finally I have minus 20. Okay? Because even though they're not there, they're coming. They will show up. All right, so let's start with our synthetic division. What goes there? Positive 2. And then I list out all of my coefficients from what I just created. 1, 0, 0, negative 3, 0, negative 20. What happens here? Okay, well, you go ahead and start working. Follow the procedure. And then I'll come and I'll pick up in a second. Multiply, add, until you can't multiply, add anymore. And when you write your stuff out, you need to leave some space so that all your numbers aren't crunched up on top of each other. When you get to the end, finish it out completely. Put your variables also. Then we're going to check and see if you've got the same thing I'm going to get. What you mean? Just start with the one less than this. So 4/3 squared first. And it's going to go straight down in order. All right, 2 times 1 was 2. When I added, I got 2. 2 times 2 is 4. When you add, you get 4. 2 times 4 is 8. You got a positive 5 here. 2 times 5 is 10. Add it up, you get 10. And 2 times 10 was 20. Which means I had no remainder. Okay? If the first exponent on my z was the 5th power, what's the first exponent in my answer? The 4th power. And then I just go on down the line. Z to the 4th, z cubed, z squared, z, no z. But you need to put your little addition signs. This is positive, 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 positive. And there was your answer. Who is totally and completely confused? you being honest. Would you tell me anyway? Okay.
What did the Z5 do?
Well, what you're doing is you're dividing this by this. But just imagine in your head, if I have a Z to the 5th power and I'm dividing it by a Z, what happens? It cancels and I'm just left with Z to the 4th. Okay, so it's always going to be one less. All right, now, Parker is very anxious to know, what do we do if the coefficient is not 1? And I'm going to tell you. All right, let's look at an example right here. All right, as I'm writing the problem, I'm using the example on page 235, example number 5 in your book. As I'm writing the problem, to save space, I'm going to go ahead and insert the missing variables. I've got 8x to the 4th, and then there is no x cubed, so I'm going to insert, can't talk today, a 0x cubed. Then I have minus 4x squared, and I have an x, and then I have a constant. And this is being divided by 2x plus 1. All right, so in order to make synthetic division work, you can't have a number in front of the x because we don't even put it in the problem while we're going through the process, are we? Or do we? So what do? Whatever this number is, if I want to get rid of it, how do you get rid of a 2 times x?
9.
You divide by 2, right? But in order to keep this fraction correct, that means that every single term that exists in that fraction needs to be divided by 2. The 8, the 0, the negative 4, the 1, the 4, the 2, and the 1 all need to be divided by 2. So if I divide everything by 2, this becomes 4x to the 4th. What's 0 divided by 2? Still 0, minus 2x squared, plus 1/2 x, plus 2. Don't freak out with the 1/2. God bless you. And in the denominator, when I divide 2x by 2, I get 2. I get x. And when I divide 1 by 2, I get 1/2. Is anyone lost? Nick, you have a confused look on your face.
Why do you divide the bottom? Why do you divide the bottom?
Because I'm trying to keep the fraction consistent and the same as what it was before, equivalent. For instance, if I had 10 over 6, and I want to reduce 6 by 2, don't I have to also reduce the 10 by 2 in order to still make it represent the same amount?
Yes. No. Yes.
Yes. Okay. 10 over 6 is reduced to what? Five-thirds? Okay. Is that still 10 over 6? Yes. If I wanted to change this number, well, let's say I want to change this number to a 1. I'm going to divide it by 2, right? Well, it's no longer 10 over 6 if that's all I do. So I've got to divide everything by 2. So this is 3 plus 2 over 2 plus 1. And I still have 5/3. Okay, so when we're working with variables and all of these terms, it's the same thing. In order to make the end product still